In the 2 videos I've done so far on Jedi Survivor, I've got some pushback in the comment sections, and this video is responding to that. What is it about? Well, in the 2 videos I've done so far, the first, before I had the game to test, and I was just going off of launch review stuff that was available, and then in my own testing that I did last night on my high-end system with the 7800X 3D and the RTX 4090, I claimed that the vast majority of the performance issues in the game, causing the game to not run at a very high frame rate for people, are related to a CPU bottleneck. Now, the game also is very heavy on VRAM usage, but that's not really what I was focusing on. I was talking about the CPU bottleneck even on the 7800X 3D, which is at least tied for the fastest gaming CPU in the world. Now, some people were saying try it out without the 3D V-cache because maybe it would benefit from the higher clock speeds. Some people were just flat out saying, though, I'm wrong, calling what we're seeing here in Afterburner a CPU bottleneck. So in this video, I'm going to test this out on multiple CPUs, except I can't. Okay, so I'm gonna respond to all this, and I have a roundabout way of getting there. But okay, so in just other complaints about this game, even though I bought it on Steam, it still opens through the EA launcher. And here's why that's a problem. If the EA launcher decides that even though I own the game and I own multiple PCs, I'm not allowed to play the game that I own on multiple PCs. I posted about this on my community page this morning. I literally just opened it on 2 PCs and changed the GPU in one of them because I wanted to get some A/B testing of the same scene on different CPUs. But even though I own all of these things and I paid for the game, the EA launcher tells me that too many computers have accessed this account's version of Star Wars Jedi Survivor recently. Please try again later. So basically, I have my hands tied on how much hardware I can actually test in this game because EA decided, I guess, I don't actually get to play the game that I own on the PCs that I own. So anyway, I get that they're trying to limit account sharing. So like, I don't give my password to 1,000 people who can all play the game on my one copy. But guys, this is just such a stupid way of doing this and punishing people who actually want to buy a game legitimately. I'm not promoting piracy, but when you make pirating a game a better experience than paying for it legitimately, I maybe see why people do. Anyway, so, EA, if you're listening to this, could you please switch this whole thing to just don't let the same account, which owns the game, run on 2 PCs at the same time? So I can run it on 2 different PCs, just not at the same time. That's all I want. Just like, I don't think it's that unreasonable. I'm going off on a tangent here, not the main topic of the video, but is it that unreasonable that a person, I get that I'm a game tester, but could a person have a PC in their office, a PC on their TV, and then maybe a gaming laptop? I don't think that's that unreasonable of a setup. And that's literally all I did here. I only did 2 PCs and I changed the GPU in one of them and it locked me out. Okay, that's it. That's all I did. So anyway, there's that. So that's why I can't actually give you some A/B comparisons in this. So first of all, let's talk about the issues we're seeing here, and then I will get to testing it in a roundabout way, because there are other Unreal Engine 4 games that exhibit this exact same behavior, especially when ray tracing is enabled, like, for example, Hogwarts Legacy, which you're seeing here, and also the Callisto Protocol, which I've also done an A/B comparison in, and not even just Unreal Engine 4 games. I also tested out The Witcher 3 with its ray tracing enabled, which we, again, see the same kind of behavior. Anyway, we'll get to that. So first of all, what am I looking at here? And why are people arguing that I am wrong, that this is a CPU bottleneck? Not everybody. A lot of people agree with them, but I got a lot of comments on this. Okay, so the argument is if the CPU utilization is low, it cannot be a CPU bottleneck. Okay, well, the GPU usage is also low. So in the end, something is limiting the performance of the game at all times. A game is always bottlenecked by the hardware in your PC. The question is, what part of the hardware is the bottleneck? Otherwise, you would get an infinite frame rate. Although technically the way around that would be if you actually had a frame rate limiter. So if you enable VSync or just a frame rate cap, okay, fine. Or some engines have a maximum frame rate that it allows you to reach. But assuming the engine is trying to run as fast as it can, at some point, one part of your PC is the limiting factor. Now, what I'm claiming here is that the limiting factor to the performance here is the CPU, not the GPU. The GPU is waiting for the CPU, and I demonstrated that by changing the resolution the game was running at, which changed the GPU utilization, never reaching 100%, but the frame rate didn't change because the CPU doesn't respond to frame rate changes. It's doing the same work anyway. Now, what people are arguing is, some people say the CPU has to be all the way utilized, but honestly, most games can't use 16 threads. The kind of work that a CPU does not parallelize easily. And in the end, there needs to be a main game world thread that gets all tied back together. So you can split calculations up among multiple threads, but in the end, they need to get tied back together to output the actual result at the end before you can then generate the next frame of the game. This is all very oversimplified, but that's the main idea. Here, the highest utilization we see right there is 66% on any one thread. Now, I agree that that feels weird, and that usually it's more easy to identify, oh, there's one thread at 100%, the rest of the game is waiting on that one, this is clearly a CPU bottleneck. So I agree that would be more obvious. One thing is, there's other things that CPUs do that isn't just their maximum thread utilization. They also manage like the transferring of information from storage to RAM to VRAM, all of that. And I don't believe that those transfers and other things like that that a CPU is responsible for, a common analogy I think somebody used in my comment section trying to explain what I was saying, is like a traffic cop, like managing all that information. If that's the bottleneck, it doesn't necessarily show up as a 100% utilization on any particular CPU thread, but it doesn't change the fact that the GPU cannot start calculating the next frame until the CPU is also ready to calculate the next frame. So you end up in a CPU-limited situation even when you don't see one particular thread completely maxed out. Now, people were also curious if the X3D is performing worse because some games don't really respond positively to the 3D V-cache. And they were wondering if a 7700X, which has higher clock speeds but doesn't have the extra cache, would actually perform better here. Well, once again, I can't confirm all of this in Jedi Survivor because EA doesn't want me to play my own games on my own systems. So there's that. So what do I have for you? Well, let's take a look at this footage. I'm going to shrink myself completely tiny and out of the way. What are we looking at here? Okay, so this, and I think I should be able to just play this in the background while we're going here, is Hogwarts Legacy at 1080p RT Ultra on an RTX 4090. And on the left, you're seeing my 7700X, and on the right, you're seeing my 7800X 3D. This is also an Unreal Engine 4 game, and this has ray tracing enabled, and when that happens, I'm gonna pause it here for us to look at this closely. I'm enabling all the CPU data. We can examine what's going on here. First of all, the GPU utilization is low, right? We're seeing 44% here, 55% here. The GPU utilization is higher because the game is running at a higher frame rate on the 7800X 3D compared to the 7700X. Both of them aren't giving an amazing frame rate, but again, the GPU is able to better utilize itself when the CPU is able to feed it more frames. The only change in this system is going from the 7700X to the 7800X 3D Vcache part. Now, do you see any CPU thread that is maxed out? No, the highest one we see is 66%. Interestingly enough, this is kind of random, but exactly the same thing I saw here in Jedi Survivor. And again, these are both Unreal Engine 4 games that came out recently, running with ray tracing enabled, right? This is a very similar setup. And but what we're seeing here again, though, is that changing to the X3D part, changing to a faster CPU, and this does prove that it did respond well to the 3D V-cache, did increase the frame rate, where the only changed variable is putting in a better CPU. Okay, it increased the frame rate, the GPU was able to utilize itself more because the CPU is feeding it more, and we get a higher frame rate. Average FPS improved by 17%. The 1% lows also improved. Here we're seeing like 33 versus 39, the average frame rate of 58 going up to 68. We can go ahead and play a little bit more. Now, as the resolution increases, so here we're looking at 1440p Ultra, RT Ultra, we can see that we're actually still CPU limited. Again, the best way to spot the CPU limit is just that the GPU will try to more fully utilize itself if the CPU is able to keep feeding it frames. The GPU utilization here is now 59% on the 7700X and 74% on the 7800X 3D, which again is able to feed it more frames. Here we're going from 56 average to 65 average. The 1% lows are staying fairly low on both of them. But we see an improvement here. Once again, you're not seeing any one thread completely utilized, but getting a faster CPU, increased performance. But since we're still CPU limited, the average performance difference is still about 16% between the two. If you go up to 4K Ultra, you now see that there's a very small improvement in frame rate for the 7800X 3D. Why is that happening? It's because the GPU is more often fully utilized. Here we're seeing on the 7800X 3D where I paused it at 91%, but there are times where it actually does fully utilize, which means you then become limited in performance by the GPU, by the GPU and not by the CPU. Whereas because this one is less fully utilized because it's still occasionally waiting around a little bit on that. So if you see here, we're 100%, for a second there at least, we're 100% GPU utilized, which means we're limited in performance by the GPU. You get the idea. So we get a small improvement at 4K RT Ultra, which is actually interesting because that means that a 7700X was at least somewhat CPU limiting the RTX 4090 at 4K ray tracing ultra settings, which is kind of ridiculous. And by the way, it wouldn't be unreasonable to enable DLSS quality when you're playing at 4K. And when you do that, we're once again seeing that the GPUs are not fully utilized because by lowering the rendering resolution, which is what DLSS does, and then it upscales it, you're reducing the burden on the GPU. So the CPU tries to go faster, but then it fails and we reach a CPU limited situation again here where 70% usage here, 61% usage here on the GPU. And we actually get a 20% performance uplift at 4K DLSS quality RT Ultra in Hogwarts Legacy. Is this Star Wars Jedi Survivor? No, but it's the same engine with ray tracing enabled, getting us similar frame rate issues and similar CPU utilization issues. So here's where I'll mention that some people are saying that I'm not wrong that the GPU is waiting on the CPU, but that I'm wrong to call this a CPU bottleneck because the problem is the coding of the game. Okay, I see your point there, but here's my answer to that. The code of the game is being executed by the PC's hardware, right? The PC's hardware is executing the code. So the code is asking the PC to run it, and which part of the PC is struggling to run the code more and limiting the overall performance of the game. It's very clearly identified here that it's the CPU that is struggling more to run the code effectively. So is it the fault of the game code? Well, the hardware is executing the code it's been asked to execute, and it's clearly struggling to produce high frame rates on a very powerful gaming CPU, and it's clearly not effectively using most of the cores and threads. So yes, that is because of the code it's being asked to execute, but in the end, that doesn't mean we're not limited in performance by the CPU. In the end, something is limiting your performance, or else you would have an infinite frame rate. You see what I'm saying, okay? Now, if you're not convinced by Hogwarts Legacy, how about the Callisto Protocol? This is another game that runs on Unreal Engine 4, and it's another recent game on Unreal Engine 4 that has ray tracing. And here is the game running at ultra settings with the max ray tracing turned on, again on the 4090, looking at the 7700X versus the 7800X 3D. Here the overall frame rates are better, but in the end, you can see the GPU utilization is 47% on the 7700X here, 59% on the 7800X 3D, and we are getting a higher frame rate on the 7800X 3D. So neither of these is allowing the GPU to fully utilize. So in both situations, we see a CPU bottleneck. And in both situations, None of the cores or threads are showing full utilization, but it is very clear that by putting in a better CPU into exactly the same system that the frame rate increased, meaning that we are witnessing a CPU limited situation. Again, the CPU is limited in executing the code it's been asked to execute, but again, that is what it is. That's what we're seeing. So here we're seeing 1440p max RT, where we do see a 15% improvement to the averages. Again, even at 1440p max RT, the GPU is still not even close to fully utilized. Occasionally it's getting up into the 90s, but much of the time it's significantly lower than that, even on the 7800X 3D. And we could even look at 4K max, where we're now witnessing more of an actual GPU limited situation, where the GPU is up in the mid to upper 90% range. The frame rates are now almost identical, and the end result of the benchmark run was only a 3% improvement for the 7800X 3D because of the few moments when it was actually a CPU limited situation. Again, increasing the resolution has put more of the burden onto the GPU rather than the CPU. Now, this game, like Jedi Survivor, doesn't feature DLSS, but it does feature FSR2 quality. And that's what we're seeing here. I mean, it features FSR2, and I'm enabling it at the quality setting at 4K. And once again, the 4090 is so much faster than what the CPU is able to deliver in this situation. We're seeing a 12% performance improvement for the 7800X 3D over the 7700X, even at 4K max settings, which is, again, very interesting. Now, Unreal Engine 4 is not the only engine that's been having these issues. We're seeing Witcher 3 also having similar problems with ray tracing enabled. So here, again, at 1080p, to emphasize how fast can the CPU go, if I play this, we can see that the 7800X 3D running through Novigrad, just kind of up and down this street, I'm getting a 24% better average performance on the 7800X 3D, and you can also see a similar uplift on the 1% lows. Now, I will say that this game shows a little bit more of an obvious CPU limitation. Notice that we can find threads at like 80%. Here we're seeing one at 83%. So this is more of what you would usually see when you're more CPU limited, which is almost never going to be all of the threads at 100% unless you're only on like a 4-core CPU, because most games don't use much more than 4. Some will use 6 or 8, but almost none will use 16 threads effectively. So usually you're limited by 1 thread, and that's more of what we're seeing here. By the way, just if I try that same thing out at 1440p, just to use the rest of my results here, we're now only seeing a 9% average improvement for the 7800X 3D because, once again, let me go back a little bit here. We can see that the GPU here is 96% utilized, and here it's 99% utilized. So the demand on the GPU here, and the CPU is able to keep up to the point where the GPU is reaching its limit as well. It's more in balance, right? That's more of what we're seeing in that one. And then again, jumping up to 4K resolution, which we see here. We can jump ahead a little bit in the testing. At 4K resolution, we're seeing a tie on the average frame rates because the GPU is just 99% utilization all the time. And then in this case, the CPU is waiting on the GPU to deliver the next frame. So kind of interesting stuff. Once again, I did also test it out with DLSS quality, just for the sake of completion. And in this case, the GPUs are still most of the time close to full utilization, although there is enough CPU limit happening here that it does give the 7800X 3D a 6% lead on the averages in these results. So overall, I would like to have actually done the A/B testing in Jedi Survivor to prove my point, but hopefully I have convinced you now, especially using the Unreal Engine 4 games, running ray tracing, showing very similar CPU utilization where it doesn't look fully utilized, but adding the faster CPU did increase performance and helped the GPU more fully utilize, that you see my point. Also, hopefully this was just interesting because the side note here is I was actually just curious as people asked, whether or not games were responding well to the 3D V-cache when we're in this CPU-limited situation, especially with ray tracing enabled. And I think we've proved the answer is yes in Unreal Engine 4, as well as in The Witcher 3 testing here. So I think this was kind of interesting stuff, and you also get to see a interesting test case for the 7800X 3D versus the 7700X. I'll just kind of end it on this side note about CPU reviews. So first of all, I don't really review CPUs on the channel. Honestly, it takes a huge amount of time, lots of test benches that I don't have, all of that. So you get a rare one from me here. But in general, a lot of CPU reviews are of limited use in terms of the actual numbers they give you in game performance, because the games are running at unrealistic settings. What I think was interesting here, and then, by the way, that's the correct thing to do. CPU reviews should run a powerful GPU at low resolutions to induce a CPU-limited situation to show the relative performance of the CPUs. What I found most interesting in this testing is that it actually shows off that a lot of people say that at 4K resolution, you almost don't need to worry about your CPU at all. And I do not think that's the case anymore, at least when you're running an extremely high-end 4K GPU like the 4090. Because, first of all, we've seen that many recent games honestly utilize the CPU terribly and have trouble reaching high frame rates on the CPU, especially with ray tracing enabled. And I think running 4K DLSS quality when you enable ray tracing is a completely realistic thing to do. And we saw here in all three of these games that when you're at 4K with DLSS quality on a 4090, you can sometimes get a massive improvement just from going from the 7700X to the 7800X 3D. Now, if you already have a 7700X, I don't think you should run out and upgrade to the X3D unless you have a bunch of extra money lying around, because I think in a lot of situations, it's not going to help you out. But in these particular situations, I thought it was interesting finding in some actual real-world, realistic settings, 4K FSR2 quality or DLSS quality on an RTX 4090, where we actually did see meaningful differences. Anyway, I'm not trying to argue with the people in my comment section. I'm trying to help explain my thinking, and hopefully you guys found it useful and interesting. And EA, in addition to getting some better coding for the CPU utilization in this game, can we also please end this nonsense? If I paid for the game and I paid for my PCs, I should be able to run the game on as many of my PC hardware combinations as I feel like. I don't mind if you want to limit my account being open running games on 2 different PCs at the same time. That's a perfectly reasonable way to limit account sharing of games. But limiting how many PCs I can install it on, especially to something stupid like literally it was 2 PCs with 1 GPU change. I don't think that's an unreasonable thing to be able to do with the game I paid for. Anyway, I hope all of you have an excellent day.